In this chapter, we will be discussing concepts in probability. In this lesson, we will be discussing the odds for and against an event happening.
Okay, so in this lesson, we're going to introduce this idea of the odds of an event, okay, happening or not happening here. I'm going to talk about it because you hear about it all the time. Okay, when we talk about probability, you talk about chance, you talk about odds, but when we talk about odds, it's a little different than when we talk about probability. And I'll show you here in just a second. So let's just go and kind of go through this here. It says another way to describe the chance of an event occurring is with odds. The odds in favor of an event is the ratio that compares the number of ways it can occur to the number of ways it cannot occur. Okay, so think of it like that. Yeah, the odds in favor is the number of successful events compared to the number of failure events. Now think about probability. Probability is the number of successful to the total number. But that's not what we're talking about when we talk about the odds of success. The odds of success is the number of successful events compared to the number of failure events, okay? So let's say, for example, that the probability, let's say that the probability of, let's say, rain is, let's say 2/5. Okay, so out of 5 days total, or sorry, out of 5 days that are very, very similar to today, on 2 of those days it'll rain. And now the way to think about odds is that on 3 of the days it won't. So the odds that rain occurs is going to be 2 to 3. Okay, on 2 days we would expect rain. On 3 days similar to today we would not expect rain. Okay, or we would not get rain. Odds against is the number of failures to the number of successes. We just switch it here. Now, you got to remember here, or notice that when we add up these numbers, that should equal the total number, okay, that are possible here. Or when you add up these two numbers here, you're going to get the denominator of a probability question. So now we're going to take a look at some examples talking about probability, hopefully, of odds. And hopefully by the time we get through the end here, it'll make a lot more sense to you.
Out of 25 people, 10 are teenagers. What are the odds that the person chosen is a teenager?
Okay, so here we go. Out of 25 people, 10 are teenagers. So what are the odds that a person chosen is a teenager? So the odds in favor of being a teenager. Okay, well, the probability of being a teenager is going to be 10 out of 25. Okay, the odds of being a teenager is going to be 10. Okay, compared to what? Well, the number of failures. Are out of 25 people, how many aren't teenagers then? Well, the answer is 15. Okay, so 10, the odds of being a teenager are 10 to 15. Okay, now that gives you just a sense of the balance between it, okay? 10 are successful, 15 are not successful. So obviously there's more opportunity for failure than there is for success here.
Find the odds of randomly selecting the letter P in the word Mississippi.
Okay, the odds of randomly selecting that letter P. Okay, well, first of all, let's figure out the probability. I want to go back to probability because I want you to see the connection really, really strongly here. So, in Mississippi, how many P's have we got? Well, we got 2 P's, but out of how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got 11 here. So the probability of getting a P is going to be 2 out of 11. The odds of getting the P will be 2. Well, if 2 of them are P's, then 9 of them aren't. So the odds of getting a P would be 2 to 9.
A bag contains 5 yellow marbles, 3 white marbles, and 1 black marble. What are the odds of drawing a white marble from the bag?
Okay, so we've got 5 yellow, 3 white, and 1 black. Now that's, what do we got there? 8. There's 9 marbles in that bag there. So the probability of drawing a white is going to be 3 out of 9, or 1/3. Okay, the odds of getting that white would be 3, okay, to what? Well, how many marbles are there aren't white? Well, the answer is going to be 6 here. Now, something that I haven't done before because we're just introducing it, but now that we've seen this a couple times, now let's talk about this. 3 to 6 could be reduced by dividing both sides by 3. This would be the same as 1 to 2. Okay, which tells us there are twice as many, or basically in terms of successful compared to failure events here, there's only half as many successful events as there are failure events. Now, going back up to a question we did a little while ago, now that we're starting to talk about simplifying it, I could have simplified the ratio here 10 to 15, and we could have made that by dividing both sides by 5 here, 2 to 3. Okay, so the odds are 2 to 3 that that person would be as a teenager. Now, for this one that we just did a couple of seconds ago here, 2 to 9, that doesn't simplify. That's as good as that one's going to get here. Okay, so now that we've introduced this idea, you get the idea of this is successful to failure. Now we can reduce it as well and give a simplified form of the odds.
What are the odds of randomly selecting a dime from a dish containing 11 pennies, 6 nickels, 5 dimes, and 3 quarters?
Okay, so in this case right here, notice that there are actually 25 different coins there. The probability of grabbing a dime, okay, and now how many dimes? There was 5 dimes out of 25 coins here, so that's the same as 1/5. The probability is 1/5 that we're going to grab a dime. So now the odds, okay, there are 5 dimes, well there are 20 coins there that aren't dimes, okay, 20 that aren't dimes here. Now when you simplify that, you'll get 1 to 4. Now I hope this makes sense here when you compare these. Notice the probability is 1 out of 5, the odds are 1 to 4. But when you add 1 and 4, you get your 5 there. That's where the total's coming from. Remember that what we're doing here is we're splitting the entire sample space up into 2 separate groups here to get the odds.
11 poker chips are numbered consecutively 1 through 10 with an extra 6 placed in a jar. A chip is drawn at random. Answer the following questions.
Okay, this is kind of an interesting situation here. So find the probability of drawing a 6. Okay, well the probability of getting a 6, well there were 2 out of the 11 coins, chips that we threw in there. Because remember, we numbered them 1 through 10, so there's 10 coins or 10 chips right there. And then we threw in an additional 6. Okay, so there are 2 6s out of 11 coins here. Now, what are the odds, okay, in favor of the event happening of drawing a 6? Well, the odds in favor of getting a 6 would be 2 to what? Well, take 2 away from the 11. There are then 9 chips in there that don't have a 6 on them. So the odds in favor would be 2 to 9 here. Now, what are the odds against this happening? Well, we just flip that. Remember, this odds against will be failure to success, so 9 to 2. It just gives you a nice sense of the proportion of the successful and failure events.
Suppose the odds in favor of an event are 5 to 3. Is the probability that the event will happen greater or less than 50%?
Okay, now here's an interesting question. Suppose that the odds are in favor of an event are 5 to 3. Okay, so what this means, okay, here's our odds. 5 to 3. So there are 5 successful results, 3 non-successful results here. Now that's a total of 8 possible results, right? Okay, when we include them all together. So now the probability that the event will happen, okay, so let's say the probability that it occurs is going to be, well, up here we saw that this was 5 successful against 3 failures. So this is going to be 5 out of 8. And notice that, yeah, this is in fact greater than 50%, which is what the question's asking for here. Is that better than 50%? Yes, it is. Yes, it is. And you can see that here because the left-hand side, okay, is actually more than double that other side. Okay, sorry, not more than double. That was goofy for me to say here. But think of it like this. This side here is more than this side. So when you add those together here, this value is going to be more than half of the total. Is a better way to say that because this number here is larger than this number. Anyway, there you go.
The odds in favor of an event happening are given. Determine the probability that each event will happen.
Okay, so now we're just going to practice this idea of converting odds into probability. So remember that to figure out what the total is, we just add those 2 numbers together. So it's going to be 8. And this is, in this case, we're talking about the odds in favor of the event happening. So the 3 here represents successful events. So then the probability of it happening would be 3/8. Here, the total is going to be 5. The number of successful events is 4, so the probability of that event happening is 4/5. Here, the total number is going to be 12. Again, this is the probability in favor, so the number of successful events is 7, so then the probability is 7/12.
The odds against an event happening are given. Determine the probability that each event will happen.
Okay, now this one sets us up a little bit differently here. So we're still looking for the probability that the event will occur here. So now 4 and 7 is going to be 11, so we know there's a total possible of 11 events here, but this is the odds against something happening. So that means the number of successful events would be 7. So the answer here, the probability of that event happening would be 7/11. Here, the total number of events occurring is 19, and again, since this is the odds against it happening, 9 is the number of successful events, so this would be 9/19. Here, again, the total number of events is the sum of those two, so 25, and this is odds against it happening, so the number of successful events is 3. The probability that the event will happen in this case is 3/25.
The probability that an event will happen is given. Determine the odds against the event happening.
All right, so in this case we're going to go backwards here. Now, really, this is taking us a little bit further. There's another step here. This is a percentage here. This is like chance. So what this means here is we've got 35 out of 100, okay, is the probability that A will occur. So now we want the probability, to determine the odds against the event happening. Well, there are 35 successful events. We know that there are 100 events there. So if we subtract 35 from 100, we will get 65. And now we can simplify that by dividing everything through here by 5. And so we'll get 13/7. So the odds against this event happening would be 13/7. Over here, with a 10% chance of success, that's 10/100. And again, we're looking for the odds against this event happening. So there are 10 successful events. Subtract that from 100, and you're left with 90 failure events here. And I can divide both of those by 10 and reduce that to 9/1. Okay, it's 9/1 that that event, whatever that is, isn't going to happen. 85%, again, means 85/100. When I convert that into odds, I know that that's successful events, so it's going to be 85. Now, that leaves me with 15 negative events here, or failure events. So I'm going to get 15/85 against it happening. Now, I can divide both of those by 5 there, and I will get 3/17. Those are the odds against the event happening. So it's just important to remember that with odds, you could do odds in favor of or odds against. But when you do probability, really, it's always in favor of that event. The numerator is always in favor of that event. Okay, this is always the probability that the event occurs. Even if I was to say, for example, the probability that A doesn't occur, then I'm still treating that as if it's a successful thing here. Like we have successfully not seen A occur. I know that sounds kind of like double talk there, but that's how we're treating it. Whatever that event is, this is a success. Okay, the numerator in probability is a success. With odds, however, we can look at it in 2 different ways. You just got to be really clear when you're reading the question how they're asking you to read it.
The probability that Jason will receive a text message during math class is 2/3. What are the odds against him receiving a text message during math class?
Okay, so let's take a look at this. We're told that the probability that he gets a text during class is 2/3. So let's say the probability of getting a text is 2/3. So successfully getting a text is 2, okay, out of a total number of 3 ways that occur. So that means, now we're looking for the odds against him receiving a text. So the successful events are going to go at the back here. So two events where he gets a text. Now if there's 3 total, that means there's 1 where he doesn't get a text. So the odds against him getting a text, okay, this is against, would be 1/2. In other words, it's far more likely he's going to get a text in class.
A hockey game has ended in a tie after a 5-minute overtime period, so the winner will be decided by a shootout. The coach must decide whether Ellen or Brittany should go first in the shootout. The coach would prefer to use her best scorer first. Who should go first given the following information?
Okay, so in this case here, we're going to look at this in a couple of different ways here. First of all, let's take a quick look at the probability that Ellen will score a goal. Okay, now she has scored 8 goals out of 13 attempts, so that's 8 out of 13. And then the probability that Brittany scores a goal is 10 out of 17. Now, that's not, it's when it's written like that, it's not exactly clear, okay? Now, let's take a quick look at odds. Let's say the odds in favor, okay? So the odds in favor, let's say, we'll start off with Ellen. Actually, I'll do a little arrow here. I was going to do a colon there, but that probably doesn't make sense at this point. So the odds in favor of Ellen scoring would be 8. And out of 13 attempts, she missed 5 of them then. And the odds in favor of Brittany scoring were 10. And then the ones that she missed were 7 here. So 8 to 5, 10 to 7. Now, again, you might not be able to tell by looking at those, well, which is better? Okay, 8 to 5 or 10 to 7? Whoops, sorry. 8 thirteenths or 10 seventeenths? So in this case right here, what we might want to do is convert this to chance. Okay, so in this case right here, the chance, okay, that Ellen scores here, and the easiest way to do it is to go to her probability. Just make this 8 divided by 13. Just actually do that. In this case right here, this is the chance that Ellen scores is 61.5%. We do the same thing with Brittany here. We'll take 10, divide that, okay, divide that by 17. We'll convert that, and for Brittany, that's 58.8%. Now, it's a little bit clearer who he should go with. This person should, the coach here should go with Ellen, okay? Ellen is the one that you want to run with because her chance of success is slightly higher here. But we've gone through probability, and the issue here is just interpreting the fractions. Interpreting the fractions. Now, if you were to take this and divide 8 by 5, you'd get 1.6, and if you divided 10 by 7, okay, you'd get 1.4. And again, because this is a higher ratio here, and this is odds in favor, higher ratio, she's more likely to be successful than Brittany. Anyway, so a few different ways to look at this particular question.
A group of grade 12 students are holding a charity carnival to support a local food bank. The students have created a dice game that they call BIM and a card game that they call Zap. The odds against winning BIM are 5 to 2, and the odds against winning Zap are 7 to 3. Which game should Nolan play?
Okay, well, Nolan, he wants to win. He's interested in winning. I mean, who isn't? Okay. The only time that you'd be interested in a game where the probability is lower is if the reward is that much higher, right? But in this case here, we're going with the assumption here that Nolan is interested in winning, okay? And that there's no higher reward if the probability is worse here. So what we're going to do is we're going to convert these to probabilities here, because you might not be able to tell just by looking at that 5 to 2, 7 to 3, which is better. Now we're going to talk about this in a couple of different ways here. So maybe you want to convert this to the probability. So let's say, what's the probability of winning BIM? Well, okay, now remember the odds that we're given here are against winning. So these are the odds that you're going to lose this game. So that means there are 2 successful events out of 7. That's the probability of winning. Okay, BIM, the probability of winning Zap. Okay, again, this is going to be, there's 3 successful out of a total of 10. So there you go. Now, which of those is better? Which has got the higher probability of winning? Well, 2/7 or 3/10? I don't know. So maybe what we need to do here is convert this into chance. So we'll take 2 divided by 7, and that's a 28.6% chance of winning BIM. Okay, and then this over here, well, I can do this one here. This is just going to be a 30% chance of winning Zap. So it turns out Zap has the higher probability of winning. Okay. okay? So he should play Zap. Now let's take a quick look at this in another way here. These are the odds against winning. These are the odds against winning here. If I take 5, and if I just figure out what this ratio is, 5 divided by 2, okay, 5 divided by 2, I'll come over here. 5 over 2 is 2.5. Okay, in other words, there are 2.5 times more ways you can lose than you can win. Because remember, these are the odds against winning. 7 to 3, okay, if I take 7 divided by 3, that's 2.3 repeating here, which means that the number of ways you can lose, there's 2.3 times as many ways you can lose as there are you can win. So now look at this. This number is bigger. This ratio is larger. So the proportion of losses is larger with BIM than it is with Zap. Again, this tells us that we should be choosing Zap. Zap is the game that we're interested in.
The odds in favor of Patricia passing her driver's test are 4 to 3. Answer the following questions.
Okay, here we go. So poor Patricia is nervous about her driver's test, so she's figured this out here. The odds of her passing it are 4 to 3. So what are the odds against her passing? Well, we're just going to flip that around, 3 to 4. Now, what's the probability that she's going to pass? Okay, well, the probability of passing is going to be, well, the total number of events here is 7. And remember, the odds in favor of Patricia passing her driver's test are 4 to 3. So the successful events is represented by 4. These are the non-successful events. So 4 out of 7. Which means there's a better than 50% chance that she's going to pass. Hey, that's kind of positive.
In Canada, a statistical study shows that 10% of people aged 70 or over will suffer a stroke within 5 years. What are the odds against a person aged 70 or older suffering a stroke within 5 years?
All right, so questions like this can be really confusing because of the way they're worded and what we're focusing on, and it can be kind of tough here. We're told that 10% of people age 70 or over will suffer from a stroke within 5 years. So the probability of getting a stroke, okay, is 10%, or 10 out of 100, or if you want, 1 out of 10. Okay, that is the probability of getting a stroke. So the odds, let's say, in favor of a stroke, and that just kind of seems like a weird way to say it, in favor of a stroke, which is a bad thing here. But the odds in favor of, there's 1 successful event out of 9 that would be where you wouldn't get the stroke, okay? So now, but look at this, what this question says. It says, what are the odds against a person age 70 or older suffering from a stroke? Well, this is the odds in favor, so the odds against, we would flip those two. And so the answer here would be 9 to 1. In this case, we can see that the answer is going to be A.
Harvinder is considering a medical procedure where the risk of a complication is 80%. How would the odds for a complication be expressed?
Okay, now similar to the previous question, there's some weirdness in the vocabulary here, but that's okay, we'll get past this. So the risk of the complication, okay, so the probability of the complication is 80%, or 80 out of 100, or 8 out of 10. And in this case here, we might even want to simplify that because they're both divisible by 2 here, so make that 4/5. Okay, so the probability of a complication happening are 4/5. So the odds in favor, okay, of a complication, again, we're trying to look at this positively, but it's a negative thing happening here. Okay, the odds in favor of a complication, well, there are 4 ways that complication can occur. And if it's 4 out of 5 here, that means there's 1 way where the complication won't occur. So the odds in favor of a complication happening would be 4 to 1. And over here, that is option A.
A survey of Alberta students was used to estimate the percentage of students who participated in school and non-school athletics, as well as the percentage who do not participate in any athletics. The results of the survey are shown in the Venn diagram below. The odds in favor of randomly selecting an Alberta student who participates in school athletics are...
Okay, so the odds in favor of a student, an Alberta student who participates in school athletics, well, we got to look up here. Now, the total number here, because everything's written in percentage here, we're talking about 100% here. That's kind of the way our universe is looking, because everything's expressed here in percentage. This is 15%, this is 38%. Put that together. Remember, we're not interested in the non-school athletics, just in the school athletics. So we're interested in anybody that shows up in this particular circle, and that accounts to 53% when you add those up. Now, so that means the odds in favor of that will be 53. Okay, now the total percentage was 100. These are percentages here. So if you take 53 as favorable, that leaves 47 that aren't. So 53 to 47, and there's the answer right there, D, 53 to 47.